Let's do testing. This is for biology 223 genetics. And the other day in class, I did something that was, I think I calculated something incorrectly. So the issue was Archibald Garrett and his observation that the offspring of first cousins tended, or he observed this alkapnuria disease in which the urine turns black to occur in certain families and to be more common in the offspring of first cousins. And so we did a pedigree, and I think I did not intend to calculate. I was going to leave it as an exercise for the student. We cover this stuff later in the course, and the point was I did it, and I believe I did it incorrectly because I took a shortcut and forgot to include something. So we can draw a pedigree like this, and we have here the offspring of the children of two people whose parents or siblings, it doesn't matter in this case if it's autosomal, masculine and female, and we could imagine that one of the grandparents, and we just said grandfather, maybe he's a carrier. So he's a carrier, and there's a couple ways I can do this, and there's some shortcuts, and I have some extensive videos otherwise about different ways of doing this. And what I had said was, well, if he's a carrier, then the likelihood that his daughter, one offspring and one of the lines of descent of the individual in question, well, then there's a half chance that she is a carrier, and if she is a carrier, there's another half chance of that. And likewise on this side. This is a way to do it in a shortcut, and I did something wrong, which I said, okay, if there's a half chance times a half chance, there's a quarter chance of him being a carrier, yes. But what I did was, when I made the Punnett square, I said 3/4 chance of wild type gamete produce and 1/4 chance of the null alkapnuria, AKU, and that's not true. There's a quarter chance he's a carrier, so the Punnett is right. If he's, and the other way I can represent this, say, well, he's has two gametes, one wild type, one null, which means that the likelihood that his daughter, one of his offspring, receive that is 1/2. Definitely receive from the wild type parent that, and we can represent that a couple different ways. But I can say if a pool of possible gametes, so I could just say there's a half chance she's a carrier and a half chance she's homozygous wild type, and I can follow that through. Or I could say she's equivalent to plus null. Plus null diluted by wild type by a factor 2, and this offspring would be plus. So let me simplify that to say if this is 3/4, this then is 7/8 possibility. So what I'm looking at here is what kind of gametes are produced. So grandfather, everyone else can produce only wild type gametes. He could produce wild type or null. That means his offspring, who were from a coupling with a wild type, will produce a pool of gametes that are 3/4 wild type, 1/4, and then one more generation diluted by wild type is going to be 7/8. So each of these parents in issue or have a 7/8 chance of producing a wild type gamete and a 1/8 chance. And I had that wrong because I was saying carrier, and I forgot to account for the factor of 2. So if I do the Punnett square as this correctly, mother and father, 1 in factors of 8, then I can see, well, the likelihood that this individual is what we're interested in displays the phenotype by being homozygous recessive. It's 1/8 times 1/8, which is 1 in 64, which is a pretty big difference to an answer of 1/16. And if we wanted to, we could say, well, what's the likelihood of being heterozygous? Well, that's going to be both of these, which is going to be 7/64 plus 7/64. So those two together would be 14/64. And the remainder is going to be a wild type homozygous wild type is going to be 49/64. And if we add 49 plus 14, what do we get? We get 50, 60, we get 63, and then here with this one 64, so everything adds up. Okay, I'm just putting that as a correction to what we did in class. There are other videos on how to do this, these points, but until we get to those chapters in this is just to correct the mistake I made for those of you who are curious.